want to say that we switched time zones or had daylight reduction time. I don't know, but we're here. We're live, and I guess kind of like Concentric, we just keep on chipping away here. I'm here at Smith with Concentric Industries, and we're an hour late for our second edition. We're just talking about trying to improve some of the software dynamics and having our understanding on this end, and we're getting it figured out one way or the other. I'm happy to be here. Concentric Industries is in really an unforgettable position, and it's going to be a thing of the past soon, and it's fun. We get to rebuild this business again, and I'm privileged to be representing the entire company that I founded back in the 1990s, and we've got some exciting episodes coming up in this venue later. We kind of, you guys know some of the backstory. In fact, I'll read this again from what we had last time as just an intro to give kind of a sense of perspective here that, you know, why we're coming to YouTube. And we definitely will improve upon this technical performance. So for those of you who had to stay up later or this was a schedule conflict, we apologize. We are getting this worked out. Basically, just my bad on not being able to navigate the software properly. YouTube is easy to use, and we kind of made it not easy, but we'll get it dialed in here. On to the points at hand, and I read this last time. It was supposed to be an opening comment, and we'll kind of pick up where we left off from last week. This is episode number 2 here on YouTube. The bottom line with this organization is that I had an opportunity about 36 years ago when a door opened for me to step away from a very prosperous career that I'd been in for less than a decade and go on my own in the power industry, which is, I just kind of figured it made sense, and it did. Looking back on it, a little bit of a gamble of sorts, but what we did is we walked into some projects with existing clients and some firms we were working with. And the juxtaposition, so you guys can understand, we started in the power industry, and that's still what we are. And the power industry has severe limitations on what they deem feasible. And it really boils down to economy of scale, both monetarily and structurally, in terms of mechanically how big plants are and everything. And basically, the industry by and large tends to have 100 million to 500 million minimum. And we saw opportunities based on combined heat and power, customized energy production, to do projects that would be even down to $1 million level. And the challenge is, how do you make those profitable? And you look for a variety of conditions, market conditions, high power prices, high cost of fuel. Obviously efficiency makes a bigger difference. But one of the big issues was just that, having a more efficient plant, generating more revenues than just electricity. And what I found out over the ensuing decades is that perspective, while it makes complete sense, to diversify revenues or extract value from waste streams, in general, is not a popular opinion. And what's wild is, and you guys close to me on the development team, don't take this wrong, because I appreciate everybody's effort, but a lot of times people just say, that's too confusing. And people say, what's cogeneration? How can you get heat and power? All those different things. And I try to draw this analogy. This is what I'll explain to people a lot, is if you're ever driving an automobile in a winter climate and you turn on the heater, that heat's coming from your engine block, right? And it's not engine exhaust or anything coming in the cabin. It's just some air blowing across some heat exchangers that are built into the hood of the car to blow warm air into the vehicle. That's called cogeneration. You're using something that otherwise, what's that heat doing? It's just getting rejected to a radiator. Okay, so that's something most people are generally familiar with. And so That's all it is when you have a power system, there's thermal energy, there's exhaust gases, everything. We make use out of those. We said years ago that we're gonna have to make use of those to comply environmentally and also to be able to do these projects that are relatively smaller scale. And scale is relative, right? In the power industry, if you're talking a project in the $20 million range, most people in the industry are like, yeah, see you next Thursday, Charlie. Go get 10 of them and then maybe we'll think about it. Literally. And yet you go in the regular world and your average person who earns, even 6 figures a year or whatever, it's like $20 million. Who's got that? Well, that's the thing, is our business isn't based on, Bill is going to go build a power plant. That's not how it works. It's banks, groups, utilities, everything. And what happened, long story short, is we made millions of dollars, tens of millions, hundreds of millions, even in the billions of dollars building power plants. Made a lot of money, but it was kind of feast for famine, right? You build one and then you move on. You don't own and operate it. And this is a great way to make a living. So in one of the recoups we've done here coming out of COVID, is something we were always on the edge of and looking at, because we were setting these plants up to be optimized of how they operate and what goes on. So we set out to be the owner-operator, which means we also have to be the financier or pulling partners to do that. So hence the business model used to be boom, build, own, operate, maintain. Sometimes you do build, own, transfer after a performance test. Well, now for us, essentially I went to work for myself. I said, why don't we do it ourselves? If we're going to do all the regulatory licensing, which we have a perfect track record of, all the mechanical engineering, electrical engineering, civil engineering, build these plants, have them effectively get commissioned, build and start up and run, which we have a 100% success record on. I keep trying to tell people, think we're like a new company as soon as we get one built. So we built over 100. Okay, we're not pilot level nothing. I've got 24 patents. There's about 6 of them that need some R&D. I don't even talk about them in public. Everything we put a proposal on, it's been done, commercially proven. Some guys say, well, what about this? You haven't done it with this fuel at this scale, whatever. Well, here's the deal, guys. If you drive an automobile down the road and you put decent gasoline in and you're driving down the road, what's to say that you have 80 people each driving their own automobile down the road? Is that like a leap of faith? What about 81? Right, that's essentially what we're talking about. If you build a power plant that's effective, you don't need to build 462 more to prove that it works. You can build 6 at a time. You can have one plant that's the same size as some other plant that's 6 times bigger, and then you can make it with 6 of the one unit. The scalability. It's like a guy says, well, you have a sedan, can you have a pickup truck? That's not risk, okay? It comes down to an understanding that people realize what the common parts are. Well, we've whittled down everything. This is what's so cool about our company and what we've been able to pull together, is we now have like the Henry Ford Model A, one size fits all. It's omnivorous. We can use coal, oil, gas, sewage, livestock manures, plastics, scrap tires, wood, woody biomass. Anything with carbon we can use as a fuel anywhere in the process, solid, liquid, or gas. That's how versatile our system is, and it's basically a power plant, thermal energy. And when people, I've had guys say, how does it work? And if I had to pick one word, fire, right? All we're doing is controlling fire. If you look at most mechanical work, electrical work, power generation, everything else, yeah, you have hydroelectric and wind, and solar is kind of controlling fire too, right? 8 minutes later, it takes 8 minutes for a photon to get from the sun to the earth. So, that's the only fire. But basically, any of these power systems, they call them thermal power plants. Historically, you would just burn a fuel and make steam to run a steam turbine and dump the waste heat off of that to recondense the water, all do a cooling tower. And you had power plants that were about 20 to 30% efficient at best, and you had all these emissions coming from combustion. And that was a status quo for most of the Industrial Revolution. Well, all we've done, and we can do that. That's the thing. The world's running short on electricity. We can do those all day long. We've improved boiler designs, to get fluidized bed boilers versus a traveling grate, nuances there. And it's funny, and I bring that up because around the world, there's a lot of people still building power plants. And I'm going to name names. China and India are really about it. Although, and their contractors still doing them other places. That those were the standard normal for power generation in about 1950. Okay, maybe 1940, 1960 timeframe. And some of those plants still exist, World War II vintage, like in Ulaanbaatar, Mongolia. Well, they're dirty, they're inefficient. It's not it's called the Rankine cycle, burn and boil. And it's fine. It's served industry well, but it's neither the most efficient nor the cleanest, and therefore not the most profitable. So, and yet the world's short of electricity, so we could even use more of those. What we've done over the years, and we've been involved in these projects all along, the holy grail of thermal mass conversion is not burning it. It's called pyrolysis or gasification, and it's not complicated either. Okay, it's heating a fuel up without oxygen. So it won't burn, but it'll break itself up chemically to produce a solid, the char, ash, and we'll get to that in a minute, and then the volatile compounds, methane gases, CO, CO2, all that then can be used as a fuel or condensed into a liquid fuel and refined, and all that's given. The refinery industry in oil and gas has done quite well. If you look at petroleum products, fossil fuels are organic by definition with carbon. Pretty phenomenal what they've done. The big problems in it are what? Pollution, right? People say you're not being environmentally conscious. So as a young man, as a young engineer, back even before I formed this company, we set out saying, well, how could we change that? How could we not have acid rain? How could we not have excessive carbon dioxide emissions? And then how could you not have a cooling tower where you're dumping waste heat, right? And you could have an air-cooled condenser so you don't have water vapor loss. There's little nuances in there, but the bottom line is you've got thermal energy heat, and you've got carbon dioxide and other emissions coming off, right? And the 5 criteria pollutants. Do you know that if you go get a permit anywhere in the world and in America, anywhere, where it's regulated, you have 5 what they call criteria pollutants: NOx, CO, volatile organic compounds, VOCs, SOx, sulfur dioxide, and then PM10, particulate matter, usually at 10 micron level. And it's funny, CO2 is not even monitored. And yet people, that's the big issue. Well, we massage those gases in a simple way, bring it at temperature, we cool them down just enough and run them into an algae harvesting system. Because guess what? Carbon dioxide plus water plus a photon of light produces what? Sugar is one way to say it, plus oxygen. But formally, C6H6O6 is like the common glucose. But regardless of what the plant's producing, it's a carbohydrate, right? It has carbon and hydrogen. And guess what? It's also a hydrocarbon. It's so funny. We laugh about it, that you eat carbohydrates, like bread or something, you say it's carbos, carbo loading. And then when it's a fuel, we call it a hydrocarbon. Guess what the difference is? Big trivia for that. If you don't remember anything else I say, what's the difference between a hydrocarbon and a carbohydrate? Not much. That's the answer. They're basically the same thing. The chemical formula are the same. What we eat as food, as human beings, it goes in our body and it runs through, this is what's wild. It goes through the exact same chemical formulation. I'm not kidding. I mean, it's exactly the same process as when you burn a fuel in an engine or turbine. Gasoline, literally, it's called combustion. And then what's cool is the reverse of combustion, because what's combustion? A sugar, a carbohydrate, plus oxygen, plus heat produces CO2 and water, which drives back to photosynthesis. It's a complete loop, and it's been that way since the beginning of time. And it's awesome, and we forget that. CO2 is not the villain. You say, how does it work? How does it work? You harness these things. You let them do what they want to do. So what's cool is that's what we did over the years. We said, hey, we're going to take the exhaust, the emissions, turn it into algae, which is a great biomass. Animal feed, human feed, there's all kinds of cool things going on. If we have a waste-fueled power plant, if there's the chance of, heavy metals or whatever coming across, we always said we're going to use that for a fuel or do something different with it as a biomass. And again, I'll get to that in a second. But what's cool is that then on the waste heat side, again, the heat going to a cooling tower, why does it get dumped to a cooling tower? It's in the Fahrenheit range, between usually 110 and 160 or something. It's on a hot, it's not hot. You can touch it, the cooling towers are warm, and on hot days it gets really warm. Your delta T, your temperature difference between ambient and that water is going to be not much. You know, I've stood inside cooling towers in like Houston, Texas on super hot days, and it's like you're just standing inside of a sauna. You know, and your power plant performance can suffer during those times, and that's what we get really good at, is how can you make it better? Well, one way to make it better is dump that heat into something where you can use it. And lo and behold, aquaponics, right? The Inca perfected that. It's been done all along in history. You know, because what you're doing is you have fish waste. The Inca did it up in the terraces up in the Andes Mountains, you know, back 500-600 years ago. Because then the fish waste fertilizes the plants, and the plants are in a moving water bath, and they get all they need, and it's easy to harvest, roodless and stemless even. Or you have roots, but they suspend in the water, and it's awesome. We use a thing called nutrient film technique, where you can do rapid harvesting once a week and have microgreens and fish. And, you know, honestly, what I'm describing, for anybody who follows this and you look into it, it's so incredibly simple. And I get it, guys. We're working on things now. You know, we had another banker say, this is complicated. What is it you're doing? It's like we convert everything people don't want and fuels they don't like anymore into stuff everybody needs every day. You know, how else can you say it? Because you get into it, and then people, it's like this thing, you get into stuff. It's, how does a turbine work? How does an airplane fly? Most of us have never been pilots for commercial airliners, but you still get in a plane. Do you know how they fly? You have a thrust off of a turbine, a gas turbine, gives a lot of strength to weight ratio, is awesome, hanging on that wing or on the tail fin, and you get a lot of thrust, and you have the airflow, like Purdue was right, you have a wing curvature, so the air has to travel further to go above the wing, which means its static pressure drops, so the pressure below the wings more, and it lifts the plane. Just hydrodynamics, aeronautics. The point is do you really know about all that? Do you know, like when you drive your car in a reciprocating engine, yeah, piston cylinder needs spark ignition if it's gasoline, or ignition if it's diesel. You need to like analyze how your car's running every minute you're driving down the road. And that's what we're trying to tell the world, is like, hey guys, there's the power generation going on for, you know, hundreds of years now. We talked about it on this show last week. It's hard not to. Michael Faraday discovered the motor, and 10 years later, it was 1921, and then in 1931 he discovers the generator, which is just the reverse effect. And so, you know, and it gets into that thing. People come in and say, hey, he's doing power generation. You know, it's one of those things. I had a great mentor of mine tell me one time, be humble. A lot happened before you were born. And it's like we want to tell, and I'm focusing on this issue of how we're going to get closure. Because here's the deal, is that I try to tell bankers and these other people too, is like, you know what, a lot's happened. There's been a lot of power generation is an amazing thing. It drives civilization. If you don't believe that, try looking at cultures that don't have it, or hospitals that have blackouts, or cities that don't have viable electricity, or when prices are high. Look what it does to economies. You know, energy is important. So is food and water. So we've integrated a way to make all of them. And what's funny is I wrote even a handbook, and one of my favorite sayings is elegance is a virtue. Some people say kiss, keep it simple, stupid, you know, whatever. But I like elegance is a virtue. Dwight Bushnell, my college professor, who one of our patents, Bushnell Thermodynamic, is named after him. Eponymous, you know, the name Bushnell Thermodynamic, you know, he always said, never be satisfied. If you find the most elegant solution to a challenge today, great, go with it. But then keep your eyes open and keep looking for something better. And what we found is if we can get the waste of one part of a process to be the fuel for the next stage, pretty soon you can get circular. And we hit that point last year. I've talked to some of the partners in the company. It's called the Dariel 360 patent. I named it after the Dariel Pass, a famous spot between Georgia and Russia. And I was up there when I thought of it. I was out hiking with my amazing wife, Talita. We were up in the Dariel Pass. It was a thrilling moment. And she could tell I was occupied. We took pictures of it. You can kind of see it in my face. I was just it just kind of clicked in my brain because we could size everything out to make this perfect circle where we can take a solid, liquid, or gas fuels of any kind and just enter them into the process. See if it's a gas or liquid fuel, we'll make power generation first, capture those flue gases to make algae biomass, to then pyrolyze it in electric arc pyrolysis to turn it into graphene and more fuel, gas or liquid. If it's a solid fuel, we pyrolyze it first and take the gas and liquid fuels off of that and use that for the power system. And then take those flue gases off that to make algae to feed more in. And it doesn't defy the first or second law. It's a mass balance and it's an energy efficiency balance. What's cool about it is that, as I mentioned, the burn and boil type systems are maybe like 25% efficient. It's like a good rule of thumb because you got losses in the boiler and losses in the steam turbine and losses out the cooling tower and whatever. Well, when we had, if you look, piston cylinder engines, spark ignition, the Otto cycle, and especially diesel, the diesel cycle compression ignition, are still the most efficient prime movers ever developed by man. Larger gas turbines approach the same efficiency. They get some scale. But what's cool is a lot of those simple cycle are in the 40% range is relatively common. Some of the bigger, slower speed engines are in the 50 spot. Large, like frame size gas turbines and some of the larger aeroderivatives like from Rolls-Royce and GE nowadays with hotter turbine inlet temperatures um, have um, you know they're pushing that high 40s. So then you take the waste heat from those to make steam, run that through a steam turbine. That's called a combined cycle plant because you've integrated the same two cycles now, but with only fuel going into one part, the Brayton cycle on a turbine or the Otto or diesel cycle. And you end up getting efficiencies of plants that push 60%. I remember we had a plant in Central Florida in 1994 being up in the control room. We had a 30-day performance test for a custody transfer. And we went upstairs. I remember it's 1994, early 94 when it got commissioned, and up in the control room and looking at that control panel screen. And I was the resident engineer at the project, lived there from start to finish. So I had to be responsible for everything in the plant, mechanical, electrical, everything. So even during the performance test, I'm kind of out roaming the thing, looking at stuff, seeing what's going on, talking to the control room, everything. And I remember going upstairs and it's heavy when I think about it, because it was, all these projects, you bleed on them and guys bleed and you work and they all have a great challenge. And I remember 59% we hit on our electrical efficiency at that plant. At the time, it was the most efficient power plant in the world. And we won global awards for it and everything. And now that's become a common design. And we've done a bunch more and I've improved them and everything. But I remember it was that elusive 60, but nobody hit 59. So we hit 59% and it was cool. There were some, all the guys in the control room, some of the, pipe fitters, millwrights stuck around to the end, of the whole thing. And our surveyor was still there, just had some cool guys there. And it was just like, man, well done. This is the most efficient power plant on earth. And we built it and it was awesome. And so what's cool, I've smoked that record since then. We had plants in California getting up into 65, 70. How did we do it? Well, we diverted the waste heat to aquaponics because you get on a power system, you get credit for that. Your fuel is, it's a balance of your thermal energy component. And yet on an electrical basis, how do we make it better? We take the algae, pyrolyze it to make graphene is the back end component. I'll hit that in a second again still. And then more fuel. In other words, the waste makes more fuel. So we're looking at systems now that are going to be pushing the 70% mark, 70 to 75% on an electrical efficiency basis. And people look at that and say, that's impossible. Well, look at the thermodynamic cycle. You got like the Otto cycle, or diesel, or the Brayton for a gas turbine. Then you take the waste heat and run that in all with one fuel coming into the turbine or engine. You take the waste heat to make steam, run a steam turbine. That's more power without more fuel. Then you take the exhaust gases and make more fuel. So you get more and more incremental points. And people come in and say, well, that's complicated. I said, it's inevitable. You can't not do it. And why wouldn't you do it? See, I mean, it's great. Like these things, and I'm going to give an example here. And we ran into this yesterday. We had some guys saying, "Hey, they want to put in like a water filtration system at a hospital down in Africa that doesn't even have water, and they're discharging out into the ocean and everything." So they're looking at it like, "Oh, we got this special filter, and it's awesome. It's a setup that kind of came from the military, like a bivouac, portable type unit. It's like in skids, and portable containers, or shipping container type stuff. And you can imagine it's built first class, and it creates potable water from wastewaters, desalination, whatever. And it's mostly a mechanical system. It just has filtration. It's great, and it costs to run it. So the talk is guys saying, "Hey, keep it simple. We just need the clean water." But then, okay, put it in by the hospital. Where are you going to get electricity for it that's reliable? Well, that's it. See, life has been made complicated. You think you buy power from the utility, you buy fuel gas to run a boiler or, for heating somewhere, and then you have backup generators, and then you got electric chillers and absorption, and everybody's doing this for HVAC, heating, ventilation, and air conditioning to cool buildings down, and you need power and heat and cooling and all this, and they buy it all from different places. You see it all the time. It's in standard building specs and in operation specs of manufacturing companies. They're buying boilers and they're buying chillers and they're buying backup generators and they're buying all this stuff separately. And then they line it all up and say, "Wow, we got it going on." All we did is say, let's put it all together. If you're going to have a power generation system, capture the waste heat. It'll do what the boiler's doing with the same fuel you just put in the engine, or maybe a little more. And you do the balance out, it always makes money. Combined heat and power always has a positive profit and anywhere you go, because your alternative is using the same fuels redundantly and overlapping. It's just more efficient. So here's what happened, though. This is the big, amazing breakthrough. I mentioned how we can take the flue gases and make algae. And then now we can pyrolyze that because it's a biomass to feed through the electrolysis system. I'm sorry, the pyrolysis system. Electrolysis is electricity extracting hydrogen. Which, hey, by the way, I'll mention that. People are talking the hydrogen economy. That's got to be realistic. It takes energy to break up hydrogen oxygen bond, right? H2O. That's what's amazing. You know what else breaks it up is photosynthesis. It oxygenates oxygen. The force of a photon, what chlorophyll does, if you look at that, it's one of the most powerful things in the entire planet is photosynthesis. And you see it happening inside of a plant, right? And most plants look green because that's the one color they don't use, and it reflects, and you see it. Isn't that funny though? The energy it takes to oxygenate oxygen and break it free from hydrogen is what happens in photosynthesis. Is one of the most powerful things in the world, and we just take it for granted and say, "Oh, CO2 is bad" or whatever. No, it's the engine. It's the driver of life. So what we do though is electrolysis uses electricity to break it up, and it has a power demand. Well, guess what? We're driving some of the hydrogen economy because here's what happens. We take all those wastes from gas fueled plants or solid fuel, garbage, scrap tires, coal, whatever, wood, and we make graphene from it because it's an electric arc pyrolysis process. And again, it's very elegant. It's actually simpler. It's actually really simple in comparison. See, when you have boilers and if anybody's involved in the boiler industry, and if you've been in the power industry, you're familiar with a book called Steam by Babcock and Wilcox. And it's got pictures of old boilers, and it's got a history of steam. It's got a bunch of steam tables and all the charts. It's like this amazing, like museum level book, but it's also got like engineering data. It's really thick. It's awesome. But the bottom line is that when you have steam plants like that, you have options in your design. And if you guys get around it, and some of you may never do it because it's the whole industry's we're changing it. But what you have is you have high pressure, medium pressure, low pressure, because you have temperators to cool the high pressure down, and you've got feed water lines coming in, and you got multiple stages, and the boiler's got to come in at a low pressure first, and you have deaerators, and you got this whole series of downcomers and risers and boiler. It's all in there, and it's cool and it's efficient. A lot of it's factory assembled and put as units, and it's really neat stuff. And what you do, the term superheat is real. Some people, "Oh, you're making that up or something." It's true. What it is there's a saturation temperature, right? Like most people in the world are familiar that water boils if you're using British units 212 Fahrenheit at sea level or at 100 centigrade. It was designed to reflect that number. That's the basis of the Celsius scale. Well, what happens if you take steam then? What if you heated it up to 250 degrees after it boiled off? Or what if you took or to say 130 degrees centigrade? That would be called superheated because it's hotter than it needs to be a steam. And you do that in steam turbines, you create superheated steam so you don't get condensation in the high pressure buckets because that'll be like bullets getting fired into an airplane, turbine, or like as a steam turbine, they're usually stouter and everything anyway. But there's rules about that because if you do let water in there, not good. I mean, it's like explosions happen. And that Steam book by Babcock and Wilcox has pictures of some pretty crazy things that have happened over time. And all of this is then the rules for that are in the American Society of Mechanical Engineers, ASME. It's the BPVC Section 8, the Boiler and Pressure Vessel Code. And any mechanical engineer in the power industry, you know those codes. And you go line by line, here's the pipe, and by certain positions, you got to have certain alloys and all the pressure requirements and everything, highly detailed for safety. And they're great rules, ASTM, ASME, IEEE, all that stuff. America's developed some really awesome standards for that, all that stuff. So the point is, though, is that we don't have to do that. We're not really doing all that stuff. We are employing some combined cycle. If we make some steam, we'll run it through a steam turbine before we dump it out, to use as potable water because we filtered it, and we'll clean it up and then have nutrients in it because you can't have distilled water, right? That's super corrosive. But so we can basically produce a pure water from any stream. And all we do is we have a once through steam generator using the exhaust from our power system to run this water through one time, make steam, run it through a steam turbine and down again. And we will have some superheat and stuff, but relatively simpler systems. Because again, they're very modular. And in our designs, we keep it very, very simple. And we don't even have to use that steam cycle. That's if we want additional electricity production. We can use the steam somewhere else. That's what's great on all of our plants. You can use electricity. You can sell liquid fuels. You can have gas fuels you sell down a pipeline. You can make whatever foods you want in the aquaponics system. Like Tony Denti, your awesome 419 clubs. You said we could raise koi instead of food. Koi's worth a lot of money. All these really cool things going on about with graphene. And graphene, if you don't know what it is, go research it. It's basically the super material of the future. And it's awesome. It's basically atom thick carbon. And our process makes what's called FLG, a few layer graphene. It's also, we call it RIG, renewable electric arc pyrolysis induced graphene. There's a few terms there. And we've been talking to different people about that to try to keep it simple. And basically, to make graphene, you need to heat something up into the thousands of degrees centigrade for fractions of a second. And you can't really do that with open flame fire. So it hasn't really been on the radar screen of traditional burn and boil plants. But we've done stuff over the years with different forms of pyrolysis. And a lot of them historically started as you got a little bit of oxygen, so you can heat some of it up, and that serves as the heat for the rest. They were using some of that in 3,000 years ago in Egypt and the Mediterranean area to create wood gas. The Germans had to use it during World War II when the Allied forces bombed their power plants and refineries. They had no fuel left. They very quickly got into wood gasification and doing that. And you can gasify any carbon fuel that way. And the bottom line is that there's a few methods that take an internal heating that's not thermal directly, it's electric driven. And those are kind of the holy grail of it. And there's 3 of them. And I think they all have a lot of promise and they're pretty cool and they all work. There's nothing to debate that. But microwaves is one of them. There's some advantages there. In fact, one of our patents involves microwave a piston cylinder engine. I was at it was cool. That one I gave credit to. Long story short, there BMW, Bavarian Motor Works up in Munich. I found out by going to Jenbacher in Jenbach, Austria, an engine maker that's still there. GE owned them at the time, and then not anymore. Um, but a really cool industrial shop there in Jenbach. And what I found out later when I was over at the factory a few times at performance tests, buying some equipment, whatever, was that there was kind of this engineering dialogue between the automotive engineers up in Munich with BMW and these power generation reciprocating engine guys down in Jenbach, not too far from each other, just across there in the Alps. So I'm at a seminar one time for power generation, and one of the guys from Jenbach comes in and says, "Hey, man, you might want to come hear this." I'm like, "Okay, Franz, what's going on?" So we, ask a Zeichnet, and I go in, and there's in a separate part of their whole building, the guy's given a presentation about microwave ignition, the guy from BMW. And I said, "Hey, man, I got some ideas for, camless and, sparkless type ignition." He goes, "Yeah, here's the details. If you incorporate it in there, just mention my name. And, if BMW wants, or Jenbach wants a royalty, whatever, just figure, a lot of times these patents, people get into stuff and you file some patents, just put a target on your back, don't they? Sometimes, if you're familiar, and then the guy says, well, we're going to change one widget and then it's different. Our whole deal on intellectual property is go be a market leader, you know, like the guy said. He goes, "Hey, if you ever end up building those or build a prototype, just give us the nod and we'll build the main production." It's like, okay, deal, you shake hands, whatever. And then, so you have some ideas out there that you can incorporate, and guys get credit for that. And that's what we're all about, is finding the next best ways of doing things. So we have that in the works, and that's one of the six we don't really talk about because we haven't built the prototype. All the patents we talk about, everything we're talking about in our pro forma on the website, everything, it's all been done. Okay, it's all commercially proven. There's no need for pilots, whatever. And we've got our cool position in this whole industry. And this is even kind of why we're doing the show here. And I know I talked to a guy today that, yeah, we have a blockchain currency and all this stuff. But the bottom line for us, it's a fascinating story. And guys have already written screenplays about it, and there's going to be books or whatever. I really think that because it's fascinating, the storyline. And I'm immersed right in the middle of it. So I kind of saw the end from the beginning already. So it's kind of like, let's just get on with it because it's inevitable. You've heard me talk about the hockey stick curve, how the world needs as much food in the next 30 years and as much power generation in the next 30 years as food in the last 3 millennia and electricity in the last 3 centuries. So you got the human race, and how does it work and what's going on and stuff? It's like, wrong question. How about find somebody who knows how it works, and let's fund it, instead of, I mean, it's crazy. It's the weirdest thing. Like in post COVID, it's like people just sort of left their brains at the countertop. Well, we didn't. We treated it as a sabbatical and say, hey, the world's going to be in dire need when we come out. And we came out of this and we went international. We have branch offices now on 6 continents. I'm not kidding. Every week, it's like another $1 billion work scope, another potential branch office. I mean, it's just all over the place. We're the only game in town doing this. And you say, well, wait a minute. Yeah, sure. Other guys are building power plants. Other guys sell water treatment equipment. But like back to that analogy in Africa, what if you could build a combined heat and power system fueled by anything that had no pollution, reliable electricity to drive the water filtration? We might do some of it thermally, and you just fixed it. You just solved the problem. See, and that's one of the messages that I've tried to build into. In fact, we have a great, one of our things is a guy. In fact, I'm going to send that to you, Cheyenne and Brad. It's one we made up a while back. It's a cool millwright friend of mine, one of our guys. And he had just this picture. He was like near a MCC panel or something one time, or near a motor control center or whatever. And it kind of looks like he's down in the, bowels of a plant somewhere. And he's just kind of looking at the camera. And the line says, "We are Concentric. We fix everything. What's your problem?" And we should probably bring that one back to life, because you know what? That's really kind of it, is, we just fix problems, and we've developed a toolkit to just fix stuff. People say, oh, we need clean water. We don't have reliable electricity. We have waste problems. Done, done, done. Literally. And well, how does it all work? Well, what's cool, see on the Dario 360, I finally took off, it kind of amalgamates a bunch of the patents and puts a sequence together so you can just interchange it all. It's right there. Just you enter in anywhere in the circle and you just keep going around. Like Ted Decker's books, 0, 1, 2, and 3, or what was it, white, black, red, and green. He came out and, book zero, green. It's kind of, you can start anywhere in the book and it just keeps circling around. Okay, that's what ours does. That's what our technology does. You can start anywhere. So our view on that was that, hey, um, we've got it now. I tell people that the one spot and don't get me wrong, we love wind and solar too, but wind and solar don't solve baseload power problems. They also don't solve waste problems. There's also efficiency gains, and don't that's it's just news flash. When you see those big, horizontal shaft, three, blade impellers of the wind turbines, they were all driven by tax credits, just a synthetic deal. That's not the best way to generate wind power at all. There's some really cool squirrel cage stuff, vertical shaft, some really neat things. We have one that's cool. Our patented wind turbine system is there's no exposed moving parts. It uses the Bernoulli effect to harness the moving wind, draws it down into a toroidal shaft to run the impeller. It's all invisible. It's cool. So you just see it like a round device, and that's it, just sitting there like a circle, and you can have LED lights on it or something, have it be ornamental. I mean, there's just no reason you have to have bird strikes and all these other different things. And we arrange them in a way where they augment each other. It's like a school of fish, right? And it's Alien Diamond, like instead of where the turbines are interfering with stuff, the large ones, it's just not a good technology. And it still goes in because, people, they'll get tax credits and they call it green power. And then they forget that power's got to get shaped because it's not base load. And so some other turbine somewhere, a dam or something's having to regulate to maintain voltage and current stuff, operations, kilowatts, megawatts. And then you have solar's a little better because the sun's always out. So you get that 24-hour thing that's in there. And I love that. Every new roof should be solar panels, and they're finally starting to come out with roofing. Instead of putting panels on a roof, make the panels be the roof. And furthermore, have them collect the hot water system for a house, right? Which makes the PV operation more efficient, integrate it all. Simple stuff. And we're doing that. Every new roof has that and everything. So, but what happened is by pyrolyzing the solid fuel part and making graphene, and you can check the numbers, it's basically, it's worth anywhere from, and the range of it is kind of in this, you know, $10,000 a ton up to like a billion. And the stratification is kind of like you'd expect, is that a single layer of graphene, if it's done in a real pure form, can be used in semiconductors. And a microchip, with integrated circuits, might use, a microgram of it or whatever, some minuscule amount, and it goes into cell phones and everything else. And pretty soon, like a pound of graphene has gone into like, $50,000 worth of devices. And that's why it lasts. And plus it offers better, lower resistance. It's good for battery terminals, PV panels, all these applications. And what's cool about it, the low hanging fruit, it can be added to cement and asphalt. And it's cool. I met a guy today who, for the first time, Lars from Sweden. If you ever get a chance to hear this, man, great meeting you today. I mentioned graphene to him. He's like, oh, like James Tour, the guy, and awesome. I love James Tour, Rice University, amazing. I say James Tour and guy on our board, Sam Shepard, are the greatest living scientists in the world today. I take notes when I talk to those guys. Shannon Hamilton's right in there too on some algae stuff. Great bioscientists, biochemists, that kind of thing. Awesome stuff. And on Sam Shepard, valasta.net, VALASTA.net. You can see what he's doing with algae, because we perfected the use of algae in recovering, CO2 from exhaust streams decades ago. And there's a lot of ways to do it. We found one that's super robust, and we're always open to ways to add a different slight component before and after. And there's some neat guys doing stuff, and there's always people moving on and advancing. But we've got this holistic system that puts it all together, because the waste from one part of the process serves as the fuel for the next. And we've got it all integrated. And there's no other way to do it, really. It keeps it really, really simple, actually. There's no stacks, no emissions, nothing. And so what happens, though, is that the the graphene in our grade of material, the it's called few layer graphene, and it's there's some amazing words in there. We use the word turbo, oh turbo, and everything, but it comes from turbine, rotating machinery, and a turbocharger, right, in a car takes the energy out of exhaust gas to spin a turbine that's connected to an inlet fan, forcing more air into the combustion chamber, into the cylinder. And that's what's cool. A supercharger uses an electric or gear driven to force more in. A turbocharger doesn't take any excess power. It's just taking the exhaust energy out. And so that's why it's more efficient, but a supercharger kicks in right away. That's, high performance cars will typically have both. But anyway, on that whole point is that the the issue with graphene is that they call it turbostratic because it stratifies across, but it really is like one layer thick graphene. And its applications are still endless. This guy, James Tour, he developed a thing called flash joule heating. And they got a company up in Toronto, Canada, that is trying to scale it and do everything. Well, again, we came from the power industry where thousands of tons a day of fuel, and at our percentages where we make basically 10 to 20% of the incoming fuel becomes graphene, and the variances are just based on the quality of feedstock. If we have virgin coal or wood or something really consistent, we're going to get more performance. Garbage is what a lot of the numbers are based on. It's kind of worst case performance because you got a mix of everything. So the bottom line is that we've modeled our worst case numbers for performance. We've modeled our worst case numbers for cost, like the low end of the system, and we still end up with over 100 times better financial performance than a typical high efficiency power plant that we make, and a lot more than a low efficiency power plant that some people are still making. And our costs aren't much more. In fact, we just sent some quotes out because we're modular and scalable, up to Kazakhstan for some full-blown, multi-gigawatt coal systems. It would take like a couple hundred of our modular plant single unit, the pyrolysis modules that have been scaled up like the Henry Ford deal. A couple hundred of them at a coal plant still has a smaller footprint than the old coal-fired boilers setup. And again, we don't have the multi-stage boilers. Yeah, we've got, if we're doing a combined cycle steam system, it's simpler, and we still have huge efficiency gains over the burn and boil system. And we're doing relatively simple steam systems overall. And that's better, to have your efficiency gains come out of the fuel conversion to begin with. And then you're running it through more efficient prime movers, and you can stack them, just put them in a line, and you get this, we ran the statistics at 99 out to 5 nines reliability, where, at a data center, that's important. So our plant basically came out and said we would have like 30 seconds of downtime a year statistically. And by and large, that usually wouldn't even mean every unit's offline either. So you might have a zero. You might never be totally down, which is unheard of for a 1 or 2 turbine large scale plant. So really cutting edge stuff from every vantage point. But on graphene, I want to thank you guys for your patience. I know the the time getting in here late. I just apologize for that. The key is that the economics are profound. I mean, off the charts. Our work already was. Every plant we've ever built and had control over had record-setting economic performance just by efficiency alone. So we're saving money by, integrating combined heat power, or making a lot of money selling that out there, and all these things. And what we try to encourage people to do, we made a recent proposal, and Anthony Figueroa, I see your name on there. Let's get that Puerto Rico deal. He brought a great thing to my attention just recently. And here's a good example. I'll kind of bring this up as one. And this is, we're trying to do a reality check. Because if you haven't gathered, here's the crux of us. We've got the best technologies ever in the history of the world to put this stuff together.
And why is that? Because we came from the trenches building these systems. When you know exactly how the best class in the world works and you're working on it and you can figure out what would make it better, you don't have to really be that much of a genius to say, oh, let's do that a little bit different and it'll make that better. It'll increase the uptime. It'll increase the output. It'll do something positive for this plant if we replace that valve with this kind of control system, or if we do, the classic thing in the combined heat and combined cycle plants is we put in a duct burner and control that steam out, because there's always a sweet spot where you get almost like 99% efficient heat transfer when your delta T's max. Well, when you're trying to make more steam with a little more heat input, and you get to a point where your boiler's operating at a premium efficiency, for every BTU of fuel going in, you're getting another BTU of extra steam out, and then through the system. Well, there's ways to do that. That's where the control systems came in. We were doing tests like this decades ago. And then you run into banking people. Now, how's combined cycle plant? How does it even work? And it's like, you know what? It doesn't, you don't need to know. There's tons of examples out there, and we've built a bunch of them. They're all over the place. And so you come in saying more efficient. It's like, no, let's move on. Let's find the winners. Let's find people who've already been doing this. And here's the comparison though. And this, I'll kind of wrap up. I know it's coming up on an hour, and I always say that, and I talk 10, 15 more minutes, but I'll try to wrap up here in 10 minutes. And I'll use this as an example. I won't name the place. I mentioned Puerto Rico a minute ago, and I love the Antilles. In fact, and this I'm going to kind of shift this. I've never really done this. People say, "How can we help? How can we do everything?" We're raising capital. We got, as an EPC contractor, we got shut down. COVID was kind of the nail in the coffin. Okay, start over. What were you going to do? We're going to be an owner operator so we can recur those recurring revenues. So we come out with this great fleet of technologies. We've improved them even over the last couple of years radically, incorporated all the latest systems. It's awesome. And we need to raise capital to go build these plants because we're providing an own operate model. And Dennis Backey, one of the co-founders of AES, the largest independent power producer in the world, one of our clients for years, even before I started this company. That's how we kind of met, was the other company that I started with doing, it's all related. You say, hey, this guy's doing that and he's starting another thing and we need a plant here. Can you come branch off and do your own? And you walk into that because people are doing stuff and they're thinking and saying, hey, here's the future. And Dennis knew that. And he said, you're going to change the world with your technology. As I see your approach, you're scaling stuff down and you're making it more efficient, but the financing's kind of hitting a roadblock, because it used to be the plants were financeable. Bankers would say they'd be working for GE Capital or Rolls Royce or Pratt and Whitney or, Doosan or somebody. And they'd say, oh, you're going to buy 60 million worth of our equipment, boilers, turbines, everything else, for a plant that costs 100 million. Yeah, we'll finance 90 million of it. And they'd make that decision in about 45 minutes, because they're like, we want to sell our equipment. We know it works and we're going to sell. Well, that's all. GE Capital just rained on the parade. 2017, they did like Enron, just started doing funny monkey business, mixed accounting that blockchain wouldn't allow because they're cooking the books on both ends, got caught and kind of shut the whole house down. So GE Capital, they're just, GE's kind of not even what it was. I guess GE Vernova is still there with the turbine division, but it's a separate division, and they're often wind turbines and other stuff. And great, it was a great company. I think it's still probably good, uh, you know, but others have stepped up in a way, and we'll still look at things, but they sold off Yenbacher and whatever. You can kind of follow the trends in the market. We're trying to form alliances with some cool Scandinavian manufacturers and just doing some cool stuff, because we've got the pyrolysis part of the plant, the power generation part we want to own too, because we're getting ready. We're on the heels of having some of the largest, most diverse power system installations ever in world history. We've got about, like, what we have on our books right now of various signed agreements or letters of intent, whatever. We have more power generation in our books than any other company in world history. And you say, well, what are you talking about? Because by design, I know what the world needs because I've been in this industry a long time. And what a lot of it needs, our biggest competitor was to do nothing. Municipalities would say, we don't have the money. State governments, we don't have the money. It's corruption. People stealing it. We just don't have the money. And then you'd have Fortune 500 companies or someone else say, well, we got permits to dump the waste in the river, so it's non-core business. We're not going to do it. And we'd come in and say, well, what if we did it? And then the lenders would still say, well, they're still going to have to guarantee all the waste stream. So you'd be asking like Heinz frozen food or something, or Heinz potato plant. I remember out in Eastern Oregon, you guys, you as Heinz, I'm back in their corporate office in Pittsburgh, and they're the bankers are telling Heinz, look, we're going to loan the money to Smith's company to build this plant, but you guys have to guarantee all the fuels, feedstocks, and everything else. And the guys at Heinz are like, so we're going to take our plant and put it up on the chopping block to support his plant. Well, we might as well do the plant ourselves, but we won't because we don't need to, because we got a permit to dump the waste in the Snake River. And so it's like, it was the classic thing where to do nothing was our biggest competitor. So we naturally said, we want to own and operate these plants anyway. And that's what we came out with. And we're looking, and basically the part I want to convey this message to everybody, because historically as an EPC contractor, we'd build a plant. Most of the time the client would be, man, this is so good, you're not telling our competitors. You cannot advertise the details here, but like Langers and Adams Grain, and we had these just cool projects, like the most efficient power plants in the history of California. It was a great run in 03 and 04. Awesome work, super cool. It's relatively small plants, totally cool systems, win all these awards, and both clients were like, you can mention us, but you're not sharing a bit of details. In fact, some of you in America, you may have had kettle chips with organic vegetable oil. We built a power plant, a tri-generation plant, combined heat, power, and cooling, for the largest organic oil refinery in the world that has exclusive contracted kettle chips out in the Western United States. Just cool stuff. You just get around real people doing real things. And my point is that we do these plants, but you have to start over for the next job. And you'd go do a dairy project for manure and all these great things. And, manufacturing jobs, government jobs, waste to energy, the whole 9 yards, coal plants. We built and commissioned the last coal-fired power plant in the United States in Richmond, Virginia, back in, that would have been 97, 8. I remember being in the test. We were doing a performance test on it. And one of the guys, we come in and we would work out of like these temporary trailers, a lot of times just a U-Haul trailer, set up redundant instrumentation. And we'd have to run all our stuff into our own panel, and we'd bring a construction trailer, and sometimes we'd be there for a week and say, oh, let's just get a U-Haul and we'll all camp out in the back. And it was snowing in Richmond that winter. And we come in, and one of our test guys, we'd take turns and wake up every hour and go check on things, be monitoring the data and everything. And we're sitting in there, drinking coffee and whatever. And we go in, one of the guys is like, he's just so he goes, plastic. He's like wrapped up in a plastic sheet, laying on the hard bench of the back of a truck. This is stuff we're optimizing power plants. It was a cool project. But that was the one we were saying, hey, it's got to be different. And there's not been another coal plant built since then. So we're coming in trying to revitalize that coal industry. And any of you from Appalachia or the Powder River Basin in America, we have an answer. In fact, when we add the graphene component, I'm not going to mince words about it. We can resolve the United States national debt by overhauling the coal industry, pollution free. That's how good it is. It's cleaner and more profitable, shattering the paradigm. But the thing I wanted to get into and to kind of close with is that there's a project, and this is really typical. In fact, this is right down the middle of the alley. So I'm going to kind of use it as an example. And I'm going to use another in Central Asia. I'll kind of use these both. One is garbage. And there's an island community that's not real big. They have it turns out about 30 to 40 tons a day of garbage comes out off this island, or stays on it in this crappy landfill that drains leachate out into some sensitive ocean waters. And in the power industry where I came from, 30 tons a day, it's like, forget it. Way too small. Well, our system, though, we can also take legacy waste from the existing landfill, and there's, a million tons in there. So we've set up a thing where one of our modules can go in there, take all the garbage coming in, all the garbage that's in the existing landfill, and over the course of a couple of years, restore the whole land, stop the liquid drainage, and get this. It's also on an island where their electricity comes from a cable that goes undersea from the main part of the island, the country they're in. They're in the Antilles. And you come across and they get outages during storms, and they don't even have power. Plus, they're paying some of the highest rates in the world because it's all oil-fired power. and it's in the United States. We can get a qualifying facility license and guarantee buyback and everything. And we're offering savings to the people, millions of dollars a year in power savings across the island and cleaning up their garbage stream. And this isn't even the most extreme example. There's all kinds of people dying in landfills and everything. So we come into a situation with proven technologies, existing systems that we know are highly designed. We can plug and play, put them in, and solve these huge problems. Save people millions of dollars, save a community millions of dollars, clean up their environment. And I'm going to continue to say this over and over and over and over and over and over and over again, is the world needs to stop putting us on trial. There's a point where cynicism is just being a jerk, right? What is it? Love does the difference. Just saying, oh, there's a problem, and then you do nothing about it, or you shoot down the guy who brings an answer. That's called being a jerk. But love says we're going to bring in a solution and fix it. And that's what we're asking. It's like, so we're going around, and here's what's cool. Here's another example, then I'll tell you what our marching orders are and why it's cool, because it's a one-time thing. But I'll use another example. There's a country here in Central Asia that's known for its coal reserves, one of the top 10 in the world. And right now they have I talked about some of this old vintage, like World War II level Russian, Soviet boilers and steam turbines, and super inefficient, super dirty. The capital city of this nation, several million people, has such bad pollution excursions that people can't even really breathe. They got to wear masks. And I saw this statistic recently on a video that they say 400 children under the age of 4 die every year because they literally just cannot breathe. They bring them into the clinic. They've got them on, Buterol. They're just, or whatever it is for asthma, and they're doing all this stuff and trying to help the kids breathe, and they just turn blue and die. And I bring that up because we're talking to that country. We've made great proposals to them, and we bring full funding. We got partners that bring in the money, but we need agreements with people to sign so we can go forward. And we need, it's a 10% anti-money laundering thing. And as we get in our rebirth, we're looking for partners for that. And we got Alliance Insurance guaranteeing the 10% comes back. It's like, guys, we've de-risked this thing out there. And we get, it's the typical questions. I can tell anymore. I'm going to do a resonance talk on this. People take our information, and I can tell they plug it into an AI thing. ChatGPT, Claude, what are some of the Gemini, all of them. I have to check them because I'll put my own stuff in and they'll just rail on me. They don't, I'm like, hey, who wrote this and everything? I said, I'm Garrett Smith. I'm a professional engineer. I wrote this stuff up. And then they come back and say, oh, well, yeah, the heat and mass balances actually do make sense. And since you're sort of in all this, and I go, why did you just hate on me a minute ago? I just dumped this stuff in, and all you can say is it needs to be verified, looks good, all this stuff. And it's like, and then I get like that same response from people. We're talking about banking. Do you have a third party thing? You know what? How are you going to get a third party report from what? Someone who didn't develop the system. It's state of the art technology, cutting edge. Any other third party person, they're completely motivated to either steal it, and in that case, absolutely say it's no good and shut your project down. But what's amazing to me is these banks, it's like, here, I'm a professional engineer, successful track record, the whole deal, but I can't say anything. You got to go get some third party person who's never done it before and somehow come in and say it's okay. When you know what it takes to do an energy balance, just make sure that what comes out is less than what goes in, because you don't have 100% efficiency. It's not hard to do an energy balance. It really isn't. Thermodynamics is relatively easy. I think. Anyway, which is energy conversion, conversion rates. But so here's the deal. We're going to that country saying, absolutely, here's what we got for track record, everything. And you know what? Like, we have not built a gigawatt scaled coal plant yet, but we've built, 5 megawatt systems running on garbage and biomass, and it's had test runs on coal and all these things. It's like, at what point do you pull a trigger and say, look, you guys are going to have to go build a new plant anyway? because your old one's falling apart, your reliability's bad. What if you have the same price tag to build ours because our costs are comparable, same dollars per kilowatt thing? And forget graphing. We're just going to do a power plant, and it's modular and scalable and the whole deal. Like, let's call it apples to apples. And then we just ask people, and this is the message to the world for all you guys, is that two things. One is encourage people to use a proxy that's real. Some of these bankers, they act like, oh, well, they've got we're going to model that the current proxy is electricity's free and water's free. And in your system, you got to build everything. And we're going to model no revenues at all. We're just going to assume it totally fails. That's their proxy. And they come back and say, what's your balance sheet that you can lock up in real estate or liquid collateral cash to guarantee you'll pay the loan off when everything fails? And I'm just like, wow, I didn't read that, but what book's that? Just things that losers say. Because why would you go build a power plant if it's just going to fail? I mean, it's unreal to me. It's like, whoa, no, you go and get equipment that it works. Like it's like an engine and turbine. That's what amazes me is the main prime movers in power generation are no different than automobiles and airplanes, turbines and engines. And yet somehow they go in a power plant and it's risky now. It's stationary, single speed. You know how easy that is for these pieces of equipment? Now we come in, airplane stuff's hard and we trust that. It's reliable. It is. It's awesome. You know what you do with a turbine? You get it at 60 hertz in the northern America, and then 50 hertz most of the rest of the world. So you get an engine or turbine, and you fire it up and you bring it up to steady state speed. You synchronize to the grid, and then it just sits there and hums along. It's like run of the mill stuff. It's one of the things we tell guys all the time. As a power plant operator, if you're good, you're going to be bored because you'll get your plant all dialed in. You'll know exactly when your operating schedules are. And then it's like, man, this is boring. That's where we tell guys, hey, work 2 or 3 days a week. If you want, take the rest off, have your phone in case there's an outage or something, do predictive maintenance and just go enjoy a 5-day weekend. Really it's performance based. That's consent. We do that. We've done it all over. So here's the thing though. This is the big thing to keep in mind. Because everybody's talking, oh, we got to change and how we explain and all this stuff. Here's the reality, and this is how we built it. And I'm trying to kind of explain this out. And it's sort of a weird message, but it's really the one that matters. Because here's the deal. No matter what we say, cash is still king, right? Show me the money. And the perfect case in point is Elon Musk is over there. He's got a thing for Grok, the data center and everything. I think it's Mississippi or Alabama, or it's maybe Memphis. I can't remember, somewhere in central southern US. And he's got maybe Virginia even. He's got like, I don't know what it is. I saw this. I just couldn't even keep reading it. I just wanted to vomit. Because what he's done is he's put in I think it's like 80 megawatts worth. Maybe it's 800. I don't know, which is all scalable. Gas turbines come in like 20 to 200 megawatt range. Well, he went out and found some like aftermarket turbines because people panicking over data centers and there's long lead times and airplanes and you got this equipment to get. So he comes in and I'm going to say it's uh, like a couple hundred megawatts worth. So he's got like 10 gas turbines lined up to be the power generation system. No heat recovery. It's not doing combined cycle, nothing. And he barely gets the permits. That was the thing. Somebody complained, said, hey, this guy's putting in these gas turbines and no permits and stuff. And he went back and fast tracked him. He said, how do you do that? Because he's got money. He's just paying the skids. And I don't blame a guy for putting turbines in to get a thing running. But it's like, where's the planning, Elon? Come on, pay attention. He said, well, we're making so much money on the data center. Who cares about the cost of electricity? Yeah, but who cares about the environmental impact? You guys say, well, CO2 is not, you might not believe in global warming, whatever. No, there's value in it. See, we could put a power plant in, capture the flue gas, run that through pyrolysis to make more energy and graphene and pay for your data centers. Why not think ahead? Why not be innovative? And I bring that up because here's the deal. We only need to sell one entity anywhere on earth. And we've whittled our technologies down. I think I've told you, some of you guys know this. We've whittled down this modular plant, single unit, 72 tons a day in of whatever feedstock. And basically the bottom line is it's a $20 million total installed cost price tag with the power generation, the fuel conversion, emissions cleanup, the whole 9 yards. No pollution, everything taken care of, done. $20 million. Realistically, it makes about 700 million a year when we do graphing at a normal price, and we have just bludgeoned it down, and we're talking like 300 million a year now, or 200. Basically like a month simple payback kind of range. Super fast. It's a modular plant. Takes like 6 to 9 months to get installed. Again, a function of we're setting up some factories, one in Georgia, one down in Oman, and we're doing all this stuff. And it's like, guys, here's the deal: because we're going to own these plants, we're going to get cash flows out of it. So if we and here's what's cool: one of the plants that ran in India for over a year is being moved up to Yorkshire, England, under government contracts. It's insured, everything, for 3 million. We can get it fully installed, fully upgraded, everything, because we already own it. So for 3 million, we can generate 300 million a year in profits. Well, guess what we're going to do with that money? Yes, pay dividends back to the token people, but also buy some more units and keep it going. So the deal is and then what do? We go to the countries we already have signed deals with and say, hey, we're coming in. We don't need 10 cents from you people, but we're going to give you clean energy, food, air, and water. What do you think they're going to say? That's why I'm out. A lot of guys say, Smith, what are you doing? Well, I'm a project guy. I like to go find applications. So we've done over half the world now. We've modeled specifically the optimum points for nations all over the world, over 100 of them. And my goal is by this year to have every country analyzed. It's kind of, and I'm looking at it like it's going to be kind of a melancholy day when I do 192. I don't know. I'll probably save the Vatican for last or something if you count them. I still think Taiwan should be a country. We've modeled Taipei a little bit, but you know what I'm saying? Like, we'll do them all. And there's always, that's just the beginning. A lot of these plants, their first run at it. We look at some nations and model the whole thing. But here's the point: is that we're looking at the whole world to dispatch these systems. You can change the face of the planet. We're going to meet that extra food and water requirement as it goes on. But here's the deal: is and I'm all for, remember, elegance is a virtue, and I think it was Cheyenne brought up tonight. I got back. We were out today, and I came back and saw these messages. Hey, we need to simplify. And I agree. And it was like, oh, they've got to do this, this, and this. And it's like, I've been trying. Here's some of mine. I got these one pagers. It's simple, whatever. So I threw a contest out, $1 million to anybody in the company. And so I can afford that one because it'll come out of my pocket. I'll pay it out over, I think it said 4 years, $250,000 a year. To anybody, you can come up with a super simple explanation of what we do and attract funding for the first deal. And we're there. I think we're there. So you better, if you want to cash in on that, and it's a peril agreement, I've written it and I'm saying it right here. If you want to cash in on that, you better hurry, because we're talking to about 12 people that are right on the edge of that. And when we close on that, yes, out of those working funds, because here's the deal: 20 millions are budgeted CapEx. Realistically, for us, in a lot of these installations, it's going to be more like 16 to 17. We leave margin in there, profit margin for construction, buffer, whatever. It's all part of the scope. It comes out in operating profits, everything else. But yeah, we're going to kick a substantial amount of that back into these meaningful dividends on the token. It's had its hair on the dog with that whole situation, but we love the blockchain still. We want to be a shining light in the crypto space. But the bottom line is we get one funding to close for one module anywhere in the world, and we got them all over ready to roll applications, then we're done financially. We don't have to sit there and go to people and say, well, we make clean water and everything. We're going to come into place and say, hi, president, hi, governor, hi, mayor. We're moving in. And, well, you need to go through the permit. Yeah, we're ready. Zero emissions, de minimis. What do you want? 3 days? 4, 7? Does it matter? It's in that. People say, interconnect, weather power. We've done all this. We know how to deal with electric utilities, steam and hot water usage, aquaponics. We've done it all. There's no more R&D. The R&D we have as a company, and me personally, is stuff we're not even talking about here. I got some really cool, I'll tell you what, during that COVID deal, I got a chance to read some of Tesla's work. Okay. Nikola Tesla. That guy was electromechanical engineer, best ever. I mean, I put him above Faraday. Faraday's a really close second. Stuff Tesla did was incredible. And I got a chance to read what he did at Wardenclyffe and over in Colorado Springs. Pretty awesome stuff. And I applied, one of my patents involves integrating some modern control systems that didn't exist in his day. So I stood on the shoulders of a giant, and it's pretty awesome stuff. And I'll just say it's about frequency matching. And some of you who might know about it, think about it. And I'm not afraid. Okay. We've got a backstory that's awesome. A lot of people want, oh, this, that, and happened and everything else. Yeah, I got taken off the playing field before COVID. Who cares? We're back. We're here now anyway. We need some capital. We're super close to closing on a bunch of it. The returns are awesome no matter which way you play it. And the economic benefits are there. And I will close now. I know I've gone 15 minutes over, but why we do this, go back and read Simon Sinek, The Power of Why. Our why is to change cultures, to meet people's physical needs so they can knock poverty out and start to make some accurate decisions about how they live. Because I had to cross that bridge a long time ago. I said, if what I do and how I do it is so good that some corrupt government officials want to take me out, there's more at play. And I realized why we're doing it has to be that big too. And my awesome, lovely wife, Talita, that's what she's all about in the Kairos, Health, Medicine, and Justice, and ISAC's Fellowship, and all these things that are talking about embedding truth and social benefits into all of these programs. And that's our board of directors, guys like Daniel Woodruff and uh, Russ Jorgensen, back in Washington. Those are just two I'm leaving. I got Matt Tallman, just people who'd give their shirt off their back and have for people to have a better life. And now we're generating a vehicle that can make a better life for everybody involved. And this is the closing line: is there's nothing more adventurous and full of love than the quest to make the world better. That's the quest I'm asking you to join me on. Thanks for listening.